Hi, I'm Mrs. Edwards, and today we are going to algebraically combine some functions. You can combine with addition, subtraction, multiplication, and division a couple of functions much the same way that you would combine just a couple of numbers. After we have combined the functions, we'll have a resulting function, and we're going to want to find the domain of those resulting functions. Here are the rules for finding the domain. When you go to find the domain of a couple of functions that have been added, subtracted, or multiplied, you find the domain of each function separately, and then you unite them, F union G. If you have taken a couple of functions and divided them, you're going to do something similar. You're going to find the domain of each one of them separately, combine them, but you're also going to leave out any numbers that make the function you're dividing by equal 0. The easy part is going to be adding, subtracting, multiplying, and dividing the functions. The harder part is going to be finding the domain of the resulting function. So here are the rules that I shared with you in a previous lesson, just to remind you of how to find the domain for any function. Before we even get started adding, subtracting, multiplying, or dividing the functions, we're going to go ahead and find the domain of these individual functions, because finding the domain after we've added, subtracted, multiplied, or divided is going to come down to knowing the domain of the original functions and then putting them together. So if I am going to find the domain of these functions, I'm looking for any x's in the denominator, any x's underneath an even root, or if I'm taking the logarithm of something that has x. If these three features are not present, then the domain of the function is going to be all real numbers. In other words, I can substitute any number into the function and I'm not going to end up square rooting a negative. I'm not going to end up dividing by 0 or taking the log of 0 or a negative. These are the things that cause error messages. So looking at f of x, we have the square root of x plus 5. We do see a square root, so immediately what we want to do to find the domain is set the radicand greater than or equal to 0. The radicand is what is underneath the root. We're setting it greater than or equal to 0 to make sure we don't choose any x's that would make us square root a negative number. Solving this inequality, I subtract 5 from both sides, so the domain of this function is all numbers negative 5 and larger. Using interval notation, that would be a bracket negative 5 to include it through infinity. Looking at g of x, notice that the function does not have any x's in the denominator, any x's underneath an even root, or the logarithm of x. It's okay to have odd roots. You can take the cube root of negative 8. It is negative 2. So since g of x does not have any one of these three features, we know that the domain is all real numbers. In interval notation, that is negative infinity through infinity. I can substitute any number into this function and I won't have an issue. On to m of x. M of x, we see a square root, but the square root is only on the 2. We don't have any x's underneath an even root, so our function m of x does not have an x in the denominator. It doesn't have an x underneath an even root, and we're not taking the log of x. So again, the domain of m of x is going to be negative infinity through infinity, which is all real numbers. Looking at h of x, we do not see any x's underneath an even root or the log of x, but we do see an x in the denominator. So what we want to do is immediately set the denominator not equal to 0, and then we're going to solve. So I add 4, and that tells me that the only number that I cannot substitute into h of x is the number 4. So all the numbers I can substitute, the numbers in my domain, are negative infinity up to 4, parenthesis to leave it out, union, parenthesis 4 through infinity. For b of x, we have a couple of things going on. We don't have any logarithms, but we do see that there's an x underneath the root, and we also have an x in the denominator. That means we need to address both issues, but we can only do them one at a time. Let's start by setting the radicand, what's underneath the root, greater than or equal to 0. When I solve by subtracting 5 from both sides, I find out that I can use all numbers -5 and larger. But I also need to address this x minus 1 in the denominator. So I set that not equal to 0 and solve, which tells me that I cannot use the number 1. If you picture a number line and you're thinking, I can use the number -5 and every number bigger than -5, however, I can't use the number 1. We're going to have to leave that out. So using interval notation going from left to right, I'm going to be able to use the number -5, so bracket, through the number 1, but a parenthesis leaves it out, union, parenthesis 1, to continue leaving out that 1, and then we can use every number after 1 through infinity. Now that we've found the domain of each one of these functions, we're going to start adding, subtracting, multiplying, and dividing these functions. And afterwards, we'll find the domain of the resulting function. Here we go. Let's add, subtract, and multiply the functions f and g. I want you just to notice the notation there though, f plus g of x. That is the same thing as f of x plus g of x. If I'm going to add the functions together, I'm just going to put them side by side with a plus in between. If you really wanted to, you could find a common denominator by multiplying the numerator and denominator of root x plus 5 by x minus 1 over x minus 1. But I don't think that really makes it much more simplified in that case, so I'm going to leave it alone. If I want to subtract them, I'm going to do the same thing. I'm just going to put them side by side with a minus. The only thing that I would mention to you is to be careful when you're subtracting functions, because whatever you replace g of x with, and you have a minus here, you might need to distribute that negative all the way through to simplify. When multiplying the functions, I just put them side by side with a multiplication. I am going to go ahead and simplify that one just a little bit. The square root of x plus 5 is the same thing as root x plus 5 over 1. So multiply across, multiplying numerators times numerators, denominators times denominators, we have this final answer. And then now we've got to find the domain of the result. And so we want the domain of this new function here. We want the domain of the that difference, and I want the domain of that product. Well, the rules for finding domain of functions that have been added, subtracted, or multiplied are the same. So you start by finding the domain of each one of the original functions, which we already did. So a quick reminder, the domain of f was the numbers -5 and larger, and the domain of g is don't use the number 1. F union g means you're going to unite them. You've got to only choose numbers that work in both. So if I want to combine those, and I'm going to use numbers that are -5 and larger, but I'm not going to use the number 1, well, then I'm going to use -5 through infinity and just leave out the number 1. So my final answer for all three of these, the domain of the sum, difference, and product of these functions, is bracket -5 through 1, parenthesis to leave out 1, union, parenthesis 1 to leave it out, through infinity. Every number in these intervals, I can substitute into the result that we got, and we won't end up with an error message. In other words, we won't square root a negative, we won't ever divide by 0 or take the log of a negative or 0 number. In the first example, we added, subtracted, and multiplied the same two functions, and I did those ones together because finding the domain of the sum, difference, and product, you find it exactly the same way. But now we're going to find the answer to f over g of x, which is the same thing as f of x divided by g of x. And then we're going to find the domain, which there's an extra step. All right, so finding f of x divided by g of x, I wrote down f of x over means divided by, so I went with that. And then when you are dividing and there's a fraction, you want to take the reciprocal of that second fraction and then multiply across. I think of it as flip the guy and multiply across. And we end up with that. Be careful that you keep those parentheses. You don't want to have x minus 1 next to root x plus 5, because then we would end up with x minus the square root of x plus 5. Important to keep those parentheses. Okay, now we have the answer to the quotient of f and g, and now we want to find the domain of the result. When you're finding the domain of two functions that have been divided, you want to consider three things. The first two are exactly the same as what we did for adding, subtracting, and multiplying. We want to find the domain of each one of those functions, f and g, and combine it. And then we also want to make sure, because you never want to divide by 0, so we want to make sure we don't use any x's that make this g function equal to 0. So f union g and the g function does not equal 0. Reminder, we already found the domain of f, and that was our numbers needed to be -5 or bigger. We found the domain of g. We cannot use the number 1 there, but now let's focus on making sure we don't pick an x that makes the function we're dividing by equal to 0. So I'm setting the entire g function, because that's the function we're dividing by, not equal to 0. Now, I know that it's easy to mix these two together. We're not finding right now the domain of g. We're finding any numbers that would make this fraction, the g function, equal 0. If a fraction is going to equal 0, the only way that happens is if the numerator becomes 0. You can think of solving this by multiplying both sides by x minus 1, and then the x minus 1s are gone. I think of it as the only way a fraction becomes 0 is if its numerator becomes 0. Okay, so either way that you look at it, and then next, to get x by itself, I'm going to divide both sides by 2, and so x cannot equal 0. Notice if I substitute 0 back into this g function up here, that would be 2 times 0 divided by 0 minus 1, which is 0 divided by -1, which is 0. We found the number that makes the function we're dividing by equal 0. So we cannot use that number either. Let's put the three of these pieces together, and we're going to use numbers, the domain numbers for f, so -5 and larger, but we can't use 1, and now we also cannot use 0. So combining all that together, we're going to use -5 up to 0 and leave 0 out. Leaving 0 out, we can use all the numbers after 0 up to 1. Then we're going to leave 1 out, both sides here, and then we can use any number after 1. Here's our interval notation for numbers -5 and larger, leaving out 0 and leaving out 1. I'm going to do a third example of two functions that have been divided because I think finding the domain when functions have been divided is the hardest because there's that extra step. So m divided by g of x, m divided by g of x really means m of x divided by g of x. So I'm going to have my m of x in the numerator and my g of x in the denominator. And that is the answer to the quotient of m and g. To find the domain of the answer of 2x plus 5 over root x plus 3, you are not just looking at that fraction all by itself. We need to consider three things. We need to find the domain of m, we need to find the domain of g, and then we also want to find any numbers that make the g function equal to 0 because we're dividing by g. And any numbers that make the g function equal to 0, we need to throw those ones out as well. Domain of m. Okay, the domain of m is all real numbers. Let's look up here, 2x plus 5. 2x plus 5, that equation doesn't have any x's in the denominator, no x's underneath an even root or the logarithm of x. So the domain for the m function is all real numbers. The domain of g. Let's look at our g function. Okay, our g function, it has an x underneath an even root, so you would want to set what's underneath the root, known as the radicand, greater than or equal to 0. So x plus 3 is greater than or equal to 0, which ultimately is going to be x is greater than or equal to negative 3. Okay, and then lastly, the entire g function, whatever it is, because it's the function we're dividing by, we're going to set it not equal to 0. All right, let's reveal one more step here. So all real numbers put with, when I solve this inequality, x's that are bigger than or equal to negative 3. But when I go to solve this equation right here, again, this is not the domain. You are solving this equation and leaving those numbers out. So I would square both sides, giving me x plus 3 not equal to 0, and then I'd subtract 3 over. So x cannot be negative 3 because that's the number that makes the g function equal to 0. So let's combine all that together. The first part says we can use everything, but the second part says no, we can only use negative 3 and larger. But the third piece says no, you may not use negative 3. So now we have to leave out the negative 3. So to make all of those happy, we're going to use, I went with set notation and interval notation just in case there, but the main one I'm going to focus on here is, notice I have a parenthesis to now leave out negative 3 through infinity. So as long as I substitute numbers not including negative 3, but any number bigger than negative 3 through infinity in here, we aren't going to have any errors. We're gonna be just fine. Those are the x's we're allowed to substitute into the answer to m divided by g. Numbers you're allowed to substitute, those are called domain. That's called your domain numbers. Full circle, back to the beginning here. So a quick summary, if you were adding, subtracting, or multiplying functions together and you want to find their domain, you find the domain of each of them separately and then combine them. Now, if you're going to divide a couple of functions, then you have to add an extra step. You still find the domain of each one of those functions separately, but then you also are going to take whatever function you're dividing by and set it not equal to 0. You'll find what numbers make that function equal 0 and leave them out. So you're solving the equation. You're creating an equation, the g function not equal to 0, solving the equation, and those are the numbers you leave out. Then you're going to combine all three, and now you have the domain for the resulting function.